That does not sound like fun. This feels like we're about to take an SAT. Or like a. Yeah. Solve complete square. That sounds like fun.
You would say, let's complete the square. All of that thing, like, girl, complete square.
Are we doing big boy complete the squares?
No, I don't think that's us.
Inverse trig integration and completing the square.
Oh, maybe it is us.
They get to do little kid
Dude, I don't remember.
square.
I don't remember how to complete the square.
All you did too.
No, it's not.
And like, you'd be like, I completed the square for this, and then you'd be like,
Yeah, if you do the, yeah.
yeah, and you'd be like, you should not be so complete the square, you're too far.
Yeah, he wants you to factor.
Yeah.
The thing you like,
Oh,
together,
this is where you
multiply.
like put them.
Where'd he go?
No, I don't. I don't remember this. The last time I did this was probably math too.
Don't you have to be like, you make one?
I don't know. You make something else in square so that it all factors out nice and neat.
Yeah.
You're supposed to like.
You want to get a perfect square so you can make equal groups or something like that.
Something like that. Something along those lines. I don't remember how to do that. In conclusion, what are you saying when you're talking about that shit? Huh? Let's. I was Mr. King. I'll be using them for our class. I was looking at cards that time. I was supposed to make it place. Yeah, the
The kilo of quesadilla get a scarf.
Oh no.
Because he has a pretty nice scarf.
Yeah, charger. It under. Like. Maybe I
don't like how this website told me that.
What? I have a lot to say, but.
Oh, you gotta exchange it so the 5 is on the right side by itself. Okay, so we got AX squared plus BX plus C equals AX plus B squared plus
I'm nicer than like walking too fast.
That's why this thing is stupid. This is and this is way complicated stuff that I can do.
You should just be like, it isn't worth it. You should leave it at that. It isn't worth it, period. Not take anything, take you.
That we take in this class.
Lighter.
I did do that this year. I have all of the gaming consoles.
Good morning. See, we all found a desk. So this is what the classroom will look like on a normal basis when you come back from Easter. It's a little different, ain't it? Now, so for you guys, this is a smaller class. It's 17, 18 in here. And I have 24 desks. 23 desks. So I know that there are some people that are maybe a little trepidatious about coming back, concerned about being so close to everybody and things like that. Not to get into all the politics and everything else about it. If you are one of those people, there will be some space in here that you can kind of space yourself out away from everybody else. We will have some extra desks. I have every intention on letting you all choose your seats when you come back. I should not have to dictate to juniors and seniors, let alone the top 5% of the junior-senior class, where they have to sit in order to get their work done. So, that's my belief, at least. Questions? I got these 3 warm-up problems here for us today. Solved by completing the square, bringing back an old favorite, I'm sure. It's going to help us. We're going to need that process today. Get out our homework.
All right, so I'm pretty sure you take your beach out, right? You put that over to the dot and do this with it.
Yeah, I don't know how to do it, because I don't really want to.
I'll try. Keep going.
Okay, so then, after you take that, right, you put it back in your equation where your B term goes, and then you subtract it from your constant, right, like your +5.
Kind of. That
So like for-
creates the perfect constant.
Yeah, right, so like for the first one, your perfect square, like your actual equation is x plus 2, 1d squared plus 1.
Yep. Well, +4, not +1.
Plus 4?
Yep.
Right, but it is x plus 2 quantity squared.
Yes.
That's pretty awkward. I know it's up a little bit. Huh? Okay. So I looked up the good old continuous square, right? So basically, you take your b term, which is like a base of 4x, and you put that over to it. And then that's square, right? Because that creates a perfect square or whatever. Yeah, and then it removes an x. And then this thing says you take that and you subtract it. But then that didn't give me.
If only there was a video that I had put in the lessons for you all. If only there was a video on one of these slides that would help you with the process.
I don't know if I can pull up my video from this tab. Yeah, I emailed the person.
to online learning.
One o'clock. That Tom?
Yeah.
Yes, where else?
I'm looking at my emails. You decided to. Oh, this is what I didn't know. This helps that this doesn't fit that is that document.
You just got it in the word.
So. Since it came up before in my other class, go ahead and we'll talk about it here as well. This is where my classroom is set up currently. Where my classroom is set up currently. And this is you guys. Class. All of you, all one time. Look at those great pictures. Look at those great pictures. So as you can see, I should have 1, 2, 3, 4, 5 spare desks, provided when we are all here. If somebody's absent, it will be, of course, more than that. So, as I've stated earlier, I'll reiterate for anybody just joining us. When we come back to Easter, I don't care where you sit, you pick your own seat. If you're somebody who wants more space and you don't want everybody else around you, you feel free to take up one of these empty desks and move yourself out of the collective. Your desks are the new recommendation from the CDC, minimum 3 distance, 3 feet, front, back, side to side. Even those of you that are on a diagonal should be 3 feet away from wherever that next person is sitting. Though I would probably encourage you not to sit in the back row there in the first place, because today, and possibly, depending on how far we get today, Thursday, will be the last days that we will be doing the live stream. I have no intention on starting Unit 6 before Easter break. I don't think that would be a smart decision by any stretch of imagination, to try to get you guys to start doing a new unit and then take, 9 days off and then expect you to come back ready to go. Have a realistic expectation. Today's lesson is not easy. Forewarning. It's not exceedingly difficult either. It just requires heavy algebra today. Heavy algebra. Before we get too far into everything, I do also want to address something else here. So I've been talking with a couple of students, a handful of people, and they've told me that the complaint with the Unit 4 test and why we didn't do well was because we didn't see any problems like that in class, or we hadn't seen any problems that difficult on or before. So because it came from you guys, I thought, well, maybe this is a legitimate criticism, and I'll hear it out, and I'll go and I'll review. I value you guys and your opinion, and I've had you guys for a while, so if you don't feel like it was a fair test, I'll take a look. And I looked, and I find that criticism to be a load of crap. On my test, there are only 3 unique questions that you had not seen something similar to before. Number 2, number 15, and number 17. Number 17 is an AP released exam question that I modified slightly. Considering that you have all the resources, all the time in the world, you could have looked up how to do number 17, or you could have asked me how to do number 17, and I would have helped you at least a little bit. Those that did actually come to office hours asked me about 15, and almost all of them still got it right. And number 15 isn't a released exam question, it's just the 2 methods we discussed put together. Number 2 is the only other unique question, and it is, once again, 2 ideas put together. Everything else on your test was a variation or similar to problems that you had done. I think the issue here, gang, is that a number of you are actually being challenged for the first time in your life, where your natural ability in doing the basics, doing all your homework, doing all the notes, isn't enough to get you an A anymore, and you don't know how to respond to that. I cannot and I will not spoon feed you this curriculum. I am not physically capable of doing a problem like every problem you will see. You must learn how to study on your own, and for some of you, you don't know how to do that. You think you do, but you've never known what it is like to struggle in a math class like other kids, and now you are. You have to reevaluate how you study. It's best to learn this now with me rather than when you're paying thousands of dollars to do it at college. I will also state that some of us just fail to understand that it's not good testing practice that you all see a question like what you'll see on the test for every single question. That's not how good testing is done. That's how high school testing is done, but that's not how collegiate testing is done. You must be able to problem solve. You must be able to critical think. You must be able to adapt to new, unique questions on the fly. And also do remember, gang, this is AP Calculus. This is a class that helps determine who goes and studies math for the rest of their life and who does not. So if you're not really focused on a math-heavy field, you're not thinking computer science, engineering, architect, mathematics in general, understand what your goal for this course should be. Your goal for this course should be something realistic. If you're not aiming to go in one of those math-heavy fields, if you're not aiming to be a mathematician or somewhere right next to that, a B would be totally and reasonably acceptable here. If you're going to go into health sciences or any of the sciences really, heck, even computer science, a B would be totally acceptable and good and on track. If you're popping off an A in this class, you should be considering like architecture, engineering, mathematics as your future career. You're very talented at math. So I think some of us have to maybe realign what we're doing, what we're thinking, and also maybe set a more realistic expectation for ourselves. But the most important thing I can tell you is some of you have to figure out how to study. And with one exception, those of us that had me for AP Stats, you already know what I'm talking about. And most of those people are doing just fine. Most of those people are doing just fine. Because you already have had to adapt to, I'm not going to show you everything. I don't have time to do 5, 6 examples of each type. So I would encourage you to think about this as you prepare for Unit 5. Okay? I'm not trying to yell at you all. I heard your criticism. I just don't agree with it. I think the test was a very fair test. I think we need to adapt how we're studying. I think we need to modify how we're studying. And if you're not doing well with that, if you don't know what to do, talk with me. I'll give you some pointers on what you should try what you should do to help you better study. If you're putting in hours and hours and hours and you're not getting anywhere, then talk with me and we can talk about what practices you're doing and what you can maybe do differently to help you better study. That's why I'm here. Let me help you. And of course, some of you got to come to office hours. And some of us got to do better at asking questions. You guys, I come up here every day ready and willing to do 45 minutes worth of homework review. And most of the time, we don't do any. We don't do any. So, as many questions as we typically need is what I'm going to do up here. These are some things that we should be thinking about and focusing on going forward. Modify your studying habits, your studying techniques. The first thing I would tell you is go do problems you have not done before but have the answers to. There's a reason why I don't assign all the problems out of a section, why I do every other odd, so that you can do the other ones and still have the answer and double check. That's what you should be doing if you actually want to study. If you want to do better, that's what you should do. So, all that being stated, I didn't want you guys to think that I didn't hear. Well, first off, I want you guys to know that you can always come to me with how you feel. If you feel like a test was unfair, I want you to know you can talk to me about that. I'm not going to be, crazy. I'm mildly crazy, but not in that way. But I want you guys to understand that I hear your criticism, I'll hear your point of view, and I'll evaluate. I'm not perfect, so I might have made an unfair test, but not this time. I heard it, I checked it out, I thought it was on point. Luke?
I think that's tomorrow's.
Is that tomorrow's homework? Oh, no, that's tonight's homework. My bad.
Yeah.
Thank you, Luke. Well, nice little sneak peek of what we're going to do today, right? Thanks, Luke. See if I can click the back button without closing the window. There we go. There we go. That's today's homework. That's today's homework. Zoom in a little bit. Maybe one more. Yep. Ooh, now I don't like that. That's too close. Back up. All right, so there's some of our answers there. 43, 49 got cut off a little bit. We do have 51 through 63 on the other side. Take a second, look it over. If you can't find what you did wrong, then ask. Okay, I'm gonna go ahead and scroll down here, gang, just so that way we can see the rest of them here. There's the rest, 49, 65, and 67. Any problems that you'd like me to do over here today? Luke? 67. Parker?
53.
53. And
49.
49? Parker, Nova?
63.
6. Anything else? There is my book. There. All right. Well, let's start at the beginning. Let's work our way through. Let's start at our beginning. Let's work our way through. Start at 49. Number 49. Arc sine of 3x over x. Arc sine of 3x over x. I apologize in advance, as I'm going to probably kick the absolute crap out of these two desks here today because I'm not used to them being this close. So, number 49, we just need to find the derivative of this function here, arc sine of 3x. So, of course, all over x. So, what do we want to do here? Where should we begin with this particular problem? Okay, what did I do on my answer key? Can you tell me what the next step is? I know what it reads, but can you actually identify what that step is, what I did, what I'm applying? Awesome. Yeah, it's a quotient rule. This is a fraction. I don't see any way that I can use U substitution or anything else to do this at this time. There's no way that no trick I can pull on this to make this work. I could try to do U here for 3x, but the derivative of that would be 3. And that doesn't help me get rid of this x in the denominator. So I think the easiest way to go about this is just to set up a quotient rule, f and g. So f prime, g prime. Well, g prime's easy. That's just 1. What's the derivative of f here? What would be the derivative of arc sine 3x? If we have our books open, directly to the left, we have this nice big table that we talked about yesterday, right? Arc sine 3x, that is listed as rule number 19. That would be 1 over the root, or not 1 over. It's going to be our 3, the derivative of what's inside. We have our square root 1 minus what's inside our 3x quantity squared. Now, we're not going to leave it as 3x quantity squared. Let's go ahead and exchange it right now for 9x squared right here. Are we okay so far? Good? Okay. So as ugly as this is going to look at first, we need to start setting up our quotient rule. So, of course, we're going to have g squared on the bottom, or x squared. We have g times the derivative of f. Well, g is x, and the derivative of f is this giant mess of a fraction, 3 over 1 minus 9x squared, minus f and g's derivative, which is going to be our arc sine 3x. That's where we're at there with our next step on my key. Do we all see that now? Okay, from here down, it is just simplifying. From here down, it's just bringing things together and reducing things down. Do we need help with that part of this? Allie's shaking her head. Yes. Okay, well, there's a couple of different steps we can take here. First, let's go ahead. Let's make this 3x. Okay. Let's put the whole numerator together. Let's make one cohesive fraction in the numerator. For that to happen, I'm going to need them to have common denominators. So I'm going to have 3x over square root 1 minus 9x squared minus arc sine of 3x times our root 1 minus 9x squared all over 1 square root 1 minus 9x squared. So this allows me to bring one cohesive 3x minus arc sine of 3x times 1 minus 9x squared all over square root 1 minus 9x squared all over x squared. Which I can now unstack those ugly looking fractions. So that would be, you continue back over this way because I'm running out of space, 3x minus arc sine of 3x all over 1 minus 9x squared all over square root 1 minus 9x squared times 1 over x squared, which then I can just bring that x squared in, 3x minus arc sine of 3x 1 minus 9x squared all over x squared 1 minus 9x squared, which is my ugly, horrifying looking answer. So all I did is combine the top into one cohesive fraction and then combine my two stacked fractions together. Nothing cancels, nothing reduces. It is as hideous as they come, but it is simplified. Questions here? 49. Okay, let's go ahead. Let's jump over to 53. Next page. Same direction. Find the derivative. We have 2x, arc cosine x. And we have this minus 2, and our root here, 1 minus x squared. Yes. Okay. What do you see that we want to do here? You can see 53 up on my answer key up there in the top right. What did I do first? What is all that mess? I'm doing two separate, well, one's a product rule. The other one is just a standard chain rule. Okay? So we'll set up our product rule here for the first half, and we'll do a chain rule here on the second half. So, if this is going to be F and G, that makes F prime 2, that makes G prime. Well, once again, going back, derivative of arc cosine is the negative interior, which is going to be negative 1 over 1 minus x squared. Just getting that right off of the table from before. Number 20 in that table there, page 378. So we'll go ahead, we'll set this up. It's going to be g times f's derivative. So we got 2 arc cosine of x plus f, which is 2x, times g's derivative, which is our negative 1 over 1 minus x squared. And then we need to do the derivative of this, which I'm just going to take and rewrite as 2 1 minus x squared to the 1/2. The 2 is going to just be a standard multiplier, so I'm just going to bring that down. I'll chain rule this, so that brings me a 1/2, 1 minus x squared to the negative 1/2. And of course, times the derivative of what's inside, which will be negative 2x. Are we okay with what I have done? Okay, time for putting stuff together. Time to exercise our algebra skills and start reducing some crap down. First thing I'm going to do is 2 arc cosine x plus, I'm going to make this negative 2x over square root 1 minus x squared. Minus, we'll cancel those. That makes that easy. I'm going to get this as a fraction, 1 minus x squared, all over negative 2x again. Are we all okay with the steps I've taken thus far? Okay, what's going to happen with my middle and last terms there, gang? They're going to cancel. I got minus and negative, which becomes a plus. Boom, boom, and I'm left with 2 arc cosine of x. Questions here? Gang, I got to be completely honest. There's nothing about 49 or 53 that really is that exceptionally challenging in my mind. Use your formula and then exercise your algebra skill. There's nothing conceptually difficult about those. If we're having trouble with those, it's probably in our algebra. We're probably making simple mistakes. We got to clean up those little errors. Or we're reaching points where we're not sure what the next algebra step would be, which my response to that is grind. Grind it until you can grind it no more.
The problem I had with 53 was just like, you know how you got that big, long, like, really ugly equation? I didn't know how to, like, make that. I didn't know that you had to do a product rule and then a chain rule, because I just didn't know where to start.
And it can be. It really can be like that, Parker. First off, thanks for being honest about feeling overwhelmed with it. These problems, these ones from this section, absolutely have that overwhelming feeling to them because they are so long, because they are so unfriendly looking. They really can feel overwhelming. But the thing that I'm going to tell you is just approach it step by step with the same things that we've been doing since Unit 2. Product rules, standard derivatives, and once you get that done, just go slow, take your time, one thing at a time, and grind. Once you can get that derivative out there, the hard work conceptually is done, and now it's all just about your algebra skills, manipulating, canceling, doing all those things. That's where your Math 3 skills come back into play, your Math 2 skills come back into play. But it can be tough when you first look at it and say, okay, where do I begin? And you start building it out and you feel like you're doing something wrong because it's expanding and gets really long. Don't worry necessarily about that. This is calculus. It earns a reputation for being tough. Let's go here to 63. 63, actually, you can see up on the board as well, right? That's the one right below there. Yes, it is. 63, little different direction here for 63 and 67. I want the equation of the tangent line for this. So basically what I need to do is what I was already doing by creating the derivative, but now I'll actually need to plug in a value for this derivative to create the slope. Everything else will be created for me. When I look at 63, I already have 1/2 and pi over 3. So I already know my equation is going to be 1 y minus pi over 3 mx minus 1/2. This is what we're looking for, and what we need to do is find m. And to find m, we're going to repeat the steps we just did, except for we will actually plug in a value. So when I look at 63, I have 2 arc sine x. That should be an easy one to do. 2 arc sine x. I'm just going to treat the 2 like a standard multiplier, and I'll do the derivative of arc sine. When I go back, double check my formula, number 19, it's the derivative of the interior on top, which is 1, and 1 minus, or minus plus, minus, yes, 1 minus the x squared there on the bottom. So when I'm looking at my dy dx, I'm looking at 2 over 1 minus x squared. Are we all okay with what I've set up here, how I've started this problem out? Yes, no, maybe? Feeling good? Feeling calm? Okay. So, let's double check my answer key, make sure we're on the same page. Everything looks good so far. Okay, let's go ahead. Let's plug in our x value. Our x value here is 1/2. So I'm going to do that in black. That's going to be 2 over square root 1 minus 1/2 quantity squared. That gives us 2 square root 1 minus 1/4, or 2 3/4. Do you guys remember a great property about fractions and roots? We can split them top and bottom, which doesn't sound like it's going to be super helpful until I show you that when I split these, I'm going to get square root 3 over 2. Let's unstack our fractions here. I've got 2 times, well, actually technically divided by square root 3 over 2, or 2 times 2 over root 3. 4 square root of 3 is what we're looking at here. Wait, no. I think Mr. Kaufman did not for mistake. Let me double check my answer key, make sure I'm not screwing things up. Nope, I'm on track. I'm on track. And this is our m. If you want, you can rationalize it and make this 4 root 3 over 3. That would be okay for that as well. And that's our m. Questions? Issues? Okay, and number 67 in the same area here, just a more complicated derivative really is just 4x and arc cosine x minus 1. We'll take a look at it too. We have y equal to 4x and arc cosine x minus 1. Our function that we're going to set up here is 1 and 2 pi. So minus 1 and 2 pi. Okay, let's go ahead. Let's begin with our derivative. Of course, this is going to be another product rule. It's going to be another product rule. Here's f. Here's g. F derivative, of course, is going to be 4. G's derivative is going to be, of course, the cosine formula here. Our cosine, that's the derivative of the top, the negative, which is going to be negative 1. All over 1 minus, and it's going to be x minus 1 quantity squared. We'll probably want to reduce that later on. Okay, let's go ahead. Let's start. We're going to have g times f derivative. So arc, we're going to have 4 arc cosine of x minus 1 plus f times g's derivative. So we're looking at negative 4x over 1 minus x minus 1 quantity squared. Are we all okay with my derivative thus far? All comfortable? All good? Let's scroll down so that we can actually see 67, see where we're at. We're right here. Okay, time to plug some stuff in and reduce and evaluate. I don't want to really do too much else with it, to be completely candid. I don't want to try to simplify this down. If I'm going to plug a number in, I might as well just leave it be in this format. The number we're going to plug in here is 1, if I just don't read the wrong question. We're going to plug in 1, so 4 arc cosine, that's going to become 0, plus negative 4 over square root 1 minus 0, or just 1. So I'm looking at minus 4 here. Are we all okay with how I reduced my secondary term? Yes? Okay. What is cosine 0? What is cosine 0? Caleb, is that an answer or a? It should be pi over 2. Absolutely. Should be pi over 2. What did I put? Yeah, pi over 2. Right there. I had to find it. My work is messy. Apologize. 4 times pi over 2. Okay, let's reduce. That gives me 2 pi minus 4. 2 pi minus 4. You can either leave it like this, Or you can reduce it down, but this is your m. So over here, this would look like y minus 2 pi equal to 2 pi minus 4 times x minus y. Questions here? All right. Well, that was good practice. Good practice. I like that. Just to return or reiterate what I said earlier about our test. I didn't walk us through doing those yesterday. But you did 2 of them, actually 3 of them for your homework. 63, 65, and 67. So those would all be totally fair questions, even though I didn't do them during class. You did them during homework, had an opportunity to ask about them. I'll also stand by the number 1 most missed question for test 4 is number 16, which is almost identical to your quiz, which you all crushed. And it's almost identical to a homework problem. So I don't know why we struggled with that other than, like I said before, I think some of us are waiting too long to start. And then when we do struggle, we've passed up the opportunities to ask me questions. I'm not saying you got to do all your tests the day it opens, but I'm saying you should read it over. And if you don't know how to do a problem, you should come and bring it to me, whether that's in class now or whether it's during office hours on Wednesdays. Let's jump into what we're going to do today. For that, we need to talk about completing the square, because what we're going to do today is very simply the opposite of what we did yesterday. So yesterday we used all these nice fancy formulas on page 378 to help us do these derivatives. Okay, so today we're going to do the integrals, which means we're going to go from the endpoint of the formula back to arc cosine, back to arc sine, back to arc tangent, and those types of things. These will be much more helpful than using quotient rules or u substitution in reverse. Trust me. Now, there are some caveats to these, and part of this is that you must remember how to complete the square. How do we complete the square? Yes, remember? So, first thing we need to do is set this equal to 0, right? We need to create the perfect b value here, the perfect b and the perfect c values that allow us to get this to, x plus 2 quantity squared, x plus 5 quantity squared, or x minus 4 quantity squared. We want a case of perfect squares. We want the same number, the same group for our factoring set. So when I look at one like this here, the steps I would take is I'm going to take my b value, I'm going to cut it in half, and then I'm going to square it. This will create the perfect constant value for me. This is going to create 4. I need to get this 4 involved, so I'm going to put 5 on the other side. And I'm going to add that 4 in. And when I add it to both sides, that allows this group to become a perfect factor group of x plus 2 quantity squared. And if I want, I can bring that 1 back over, which is what we're going to talk about doing today. This works well for problems like this first one. For our second one, for this to work appropriately, you do need either a perfect square value for a, and if it's not a perfect square value for a, like 2 is not a perfect square, you must make a perfect square by dividing everything by 2 at the very beginning. So I would start with x squared plus 3 over 2x plus 1/2, which means we're doing all fractions for this set. That would be 3 over 2 quantity squared. That's 9 over 4 that we're going to add into both sides. So x squared plus 3 over 2x plus 9 over 4. equal to, this is going to be negative 1/2, or in this case 2/4, plus 9/4. 7/4 is the result. This factors into our group here. Mr. Kaufman made a mistake. Let's go back, let's fix it. I forgot to cut that in half again. This should be actually 3/4 before we square it, which is 9/16. Which means that we don't want that as negative 1/2 or negative 2/4. We want that as negative 8/16. And then 9/16, which gives us 1/16. That's better. This gives us in here x plus 3/4, quantity squared, equal to our 1/16, or when we bring that back over, 3/4 squared minus 1/16, equal to 0. Questions here? Concerns here? Does this vaguely remind you of what and how to do this? If not, I've taken the luxury of adding a slide that has a nice video to walk you back through with you completing the square examples before you get to the problems that actually involve this. I don't know if we're going to get through all this today, and that's okay. If I have to live stream on Thursday, so be it. There's no way we're not finishing Unit 5 and its test before spring break, and that's really my only concern over the remaining amount of time we have. Let's go ahead, let's jump into our lesson here today. So, looking at slide number 2, here you go. Here's the integral rules for the inverse sine, inverse tangent, inverse secant. These are the inverse rules. This is the first set. We will not be creating rules. We will not be using rules for arc cosine. We will not be doing those for arc cosecant or cotangent. These rules accommodate for that already. I will point out to you all as well, your book is not always perfect, but on page 385 is the counterpart to the table from 378. On 385, you have a number of integral rules and laws that we have talked about. 20 of them are listed there on page 385. Another point that I would probably mark with a sticky note or something to help us. That's what I would recommend. You have everything there from chain rules to our natural log rules, to your standard tangent, secants, all the way through what we're talking about today. The product rule is there, the quotient rule is there, a lot of stuff is there for you. Page 385 has that table. It's a good resource. I would definitely mark it down. Definitely mark it down. So, we're going to use these formulas today. Obviously, that's what we're going to practice. Here today. Now, a couple of things for you to look at here is for us to set this up. The real challenge is going to be what's going to happen with this denominator. That's going to be where we're going to spend most of our time, whether that's inside a root, whether that's going to be outside of it for tangent, or whether it's going to be a little bit of a mixture of both for secant. It is worthwhile noting here, of course, that A is a constant. A is just a specific number. Are we all okay here? Okay. Let's try to start with an easy one. Let's start with an easy one. Slide 3 should be an easy problem for us. So we're going to go ahead and we're going to integrate this. We're going to integrate this 1 over square root 4 minus x squared dx. Now let's think about this realistically, gang. It's got a root involved, so it's either sine or secant, right? Has to be sine or secant. Is there x in front of my root? No, so it's most likely going to be sine here, correct? Not to say we could have put an x out there, but that would make things a little bit more complicated. Okay? What is the a value in question here? It is 2. Why is it not 4, Ryan? Because it should be a squared, right? We need to think about this as not as 4, but more as something squared, 2 squared minus x squared. This is where our completed square is going to come into play, is creating this perfect square combo. Questions? Now that you know what a is, you can set u equal to x. It doesn't really have to for this problem, but it can be helpful if this was, say, let's say like a 9x squared or 16x squared, then we would set u equal to that. That makes du, of course, dx. And we can go ahead and integrate using the standard rule here. So this should just simply become arc sine over u, the absolute value. Well, in this case, or no absolute value here, sorry. This should just be u over a, or in this case, x over 2 plus c. Questions here? All right, then. Let's move on to slide 4. Let's move on to slide 4. What are we thinking here for slide 4? Let's start by defining a and u. Let's start by defining a and u for this particular problem. When I look at this one here, what do we think and what are we feeling? All right, so what are our thoughts here? I can't read your minds. Tell me what's going on, what's rolling around in the old brain. All right, Ryan, run the show, man. What you got?
If you square root the 2, wouldn't it fit with the tangent?
Okay, so if I say a is not 2, but root 2, all right, so then what's u then?
3x.
3x. So just to show this in that format, right, we would rewrite this as 1 over, right, root 2 quantity squared plus 3x quantity squared dx. Or if you do want to use the u sub and go completely with u substitution, this would become u squared. However, if we go with the full u substitution here, we can't use dx then, right? So we would have to find du, which would be 3 dx, right? Which means a 1/3 outside, so we can bring a 3 inside for our dx, right? Are we all okay so far? All comfortable so far with what Ryan and I have talked about? Okay, now you said that this fits with which one here, sir? Tangent, secant, or sine?
Tangent.
Tangent, arc tangent, right?
Right.
Okay, so what's the formula for arc tangent?
It is,
Arc tan what?
it's 1 over A, tan, arctan, x over A plus C.
1 over a, and then inside the tangent is going to be what over what?
X over A.
X over a? Is it x?
I mean, it's U over A.
I think it's u over a, and then plus c, right? And all of this is going to be times, of course, our 1/3 multiplier out in front, right? Okay, well, let's just substitute back, okay? We have a here as √2, correct? I'm just going to put those together in the front there. I've got arc sine, or arc tangent here, excuse me. U, you said, is 3x, and √2 on the bottom for a, plus c. Let's see how we've done so far, Ryan. I like the √2. I like that for a. I like u's 3x, and I like using du as 3dx. This is the same substitution we have right here, correct? We evaluate and simplify. Evaluate and simplify. Questions here? Concerns here? Okay, move on then. Slide 5. Here's a little helpful hint to get you started for slide number 5. See how far you can get without me here for slide 5. All right, where are we at here? What are we thinking? Going on, and you will not. Don't look for somebody else to do it. If you got an idea, you tell me. Parker, what you got?
Would it be a secant rule?
I think it's a secret rule, for sure. I absolutely think it's a secret rule. And what stands out to me about it being a secret rule is the fact that x is first in my root here rather than second. Right? If it's going to be a sine rule, which is the only other time I'm going to have this root at the bottom, right? Only other time I'm going to have this root at the bottom, it would be constant minus x. This is x minus a constant, right? So that is what's speaking to me about this being a secret rule. What's more is you can see that to help you out to identify that, I brought in a multiplier here. Now, the multiplier I brought in that green e to the x, that's only 1. I'm multiplying by 1. E to the x over e to the x is still 1, right? I've even split this up so that way you can see what u and a are going to be. Parker, let's make that clear in case it's not. U here should be what?
What was it?
Go ahead, look up there.
E to
What
the
is it?
x.
E to the x. A here, of course, is going to be 1. Du would be, well, the derivative of e to the x is e to the x, right? Dx, right? So this is where this is helpful to bring this in. Because if I just try to go with u here, right, I'm bringing in this e to the x on the top so that way I can actually get to du. And what's more is rather than keeping that constant as we normally do, right, if I need to bring in a 3, typically I bring in a 3 and I keep 1/3 out, right? Or if I need to bring in a half, I keep the 2 to counteract out. But this time, this is where it's beneficial to bring both parts of that multiplier in. Because the top is going to substitute out here for my du. The bottom, I can cleanly swap u squared minus a squared. Does everybody see that now? This is now our actual formula for secant, right? Parker, let's go ahead. Let's just get the general formula and then we'll swap back. So in terms of u and a, what is the formula for secant here? 1 over what?
It'd be 1/1. So it'd just be.
Well, let's go with this 1 over a for now, right?
Yeah.
And then it's arcsecant, right? Absolute value u over a, right? Plus c, correct? Now you are right when we go back. When we just go back to our x's, right? This is going to be 1 over 1, right? So that's going to go completely away. We're going to be looking at arcsecant. What we set u equal to?
E to the x.
E to the x. A is still 1, right? So really this is just arcsecant of e to the x plus c then, isn't it? I don't have to worry necessarily about e to the x in the absolute value because as we talked about before, e to the x is a positive function. And you can leave it in the absolute value bars if you want, but it's kind of unnecessary to leave them there. Sir?
So what you've done in pink is use substitution, but like
Yes, sir.
you can see it from the brown. So do you want us to still do what?
I would recommend you still do the use substitution.
Okay.
Because I think it's much easier to go here from pink to blue than it's going to be from brown back to brown.
All right.
I think that this, like, I understand what you're saying. That from this point, you can see that we're doing the secant rule. Everybody can see we're doing the secant rule, right? But I think that it really does help, especially in these formulas, to go back to u and swap back over. I really think that that works a lot better. Because if not, you're going to create some issues later on with, okay, like let's take our last example, right? So not slide 5 here, but slide 4. If I don't do that 1/3 and 3, right? Based on what Ryan told us, we knew that we were going to be doing arctangent, right? And we probably could have saw it just from root 2 squared plus 3x quantity squared. But you're going to miss that 1/3 multiplier that you also need as a part of that. And that 1/3 multiplier didn't go away when we look at the end of that question. That 1/3 is still there in the front. It's multiplied with that root 2. Questions? So that's why I say I think it absolutely is in your benefit to go ahead and do the full u substitution. It's not going to hurt you. The chances of you making a mistake doing that is pretty small. The chances of you making a mistake trying to jump brown all the way through pink, blue, and then back to brown all in one step is likely we will make a mental math error there. Everything here looks good according to my work. On the board, I left it as still in the absolute value bars, but as we talked about, it's say yesterday, I think, e to the x we know is a positive function, so we don't have to, but if you want to, you can. Okay? Let's take a step. Let's take another step. On to slide 6. On to slide 6. I gave us a hint here to help us with this one too. This is what I mean when I say rewrite as two. I mean literally rewrite them as two different derivatives, in case you're misunderstanding. I just now realized that that might not have been clear as my hint. I mean rewrite as two separate fraction derivatives. Split that numerator. I will throw this caveat out there. I told you that today could be a difficult day. I don't think it's the math that's difficult today. I think it's the problem solving, the critical thinking that can be difficult. Figuring out where or how to begin can be a challenge. Hey, look, man, it's gonna be weird when you guys are all back here. It's gonna be weird to have you guys all in here at one time. We're doing integrals, right? Like, so you tell that eventually we're not having integrals with this, and that's all that is. How are we feeling about this one? I see a couple people still working. Anybody want to jump in here and help us out? I sure would appreciate some volunteers. No, we're all good? We want Mr. Coffin to dictate to us what's going to happen? Yeah, that's not going to happen. Parker, why don't you pick somebody? Or do you want to do it yourself?
I want to do it, but
all right, man. I'll let you run class. You and Ryan today, man.
I need a little bit of help at the end.
Okay, we can do that. We can do a little help at the end.
All right. So you split the numerators into x over root 4 minus x squared. And then dx. And then plus the integral of 2 over yada yada yada. Dx.
Yeah. Right?
Yeah.
Okay. Now what'd you do?
So I found the integral of the first one.
Okay, so let's focus on that one then. A, U, what are we looking at here? What formula are we thinking?
Sine.
Okay, we're thinking sine. All right.
So A equals 2.
A will be 2, very good.
U equals x.
Well,
But x squared.
yeah, okay, well, X is fine. Whatever you want to do.
I thought it would. Ooh, whatever. Just do x squared because I think that's easier.
Okay.
And then, so D would be 2x.
Okay.
So then you could plug it all back in and, wait, don't you have to bring in 2? I messed up.
Take a look for it. Take a look for it. Does this help?
Not really.
Okay. One more step now. You see, Parker, this first one I'm not treating as though it's sine. Okay, let's back up. Back up to here. I'm not going to treat this as though it's a sine rule. You know why? When I look at the sine rule here, number 18 on this page, right? It's just du root something squared minus something squared. The problem here is that's just a 1 on the top. This is not 1, this is x. This isn't a constant on the top. I can deal with a constant being on the top because I can get rid of that easily, bring it multiplied to whatever, right? Dealing with an x up there can be a lot more difficult, okay? Not that it can't be done, but it just maybe there's an easier way. So rather than doing this, which we could have continued out that way. We could have. I say let's set u equal to the whole thing, 4 minus x squared. That makes du negative 2x. So if I bring in a negative 2 here and a negative 1/2 there to counteract that, right? I can replace this whole first one as 1 over square root u. Or u to the negative 1/2 du. Okay? Let's finish this one out here, and then we'll turn our attention to the second. This will be plus 1 for the power, correct? So this is going to become u to the 1/2 divided by 1/2 times our negative 1/2 multiplier in the front, correct? Okay, well that's just going to, these two are going to cancel. And it's going to give me negative square root, u here was 4x minus x squared. Okay? Is everybody okay with how Park and I have dealt with just the first integral alone? Yeah, but I'll go a little bit. Thank you. Time's it. Oh, we've run low on time. Yeah, we definitely not finishing this whole lesson here today. That's okay. We'll finish it up on Thursday, all right? So just a FYI, if you want to start your homework, you can, but we'll finish up this lesson on Thursday straight, okay? Where was I? Second integral. Okay. So second integral, I like the idea of using the sine rule here more for this one part because we do have a constant up here, which is going to be much easier to eliminate and for us to use that sine rule on. So this one is where I'm going to go with a and u. So I'm going to go ahead, I'm just going to pull this one over here. A here would be 2, correct? U here would be our x squared as you described, and du, or u actually would be x, and then du would be just dx. So that's kind of the problem that we were running with over here is if you set u equal to x squared, you have this problem, right? And there's no way for me to get rid of that x then on the top with dx. Does that kind of clear up why we're looking for a constant on top rather than a function of x? It all is dependent on what we're going to set u equal to. If I set u equal to just x squared here, then I have something squared minus u, which is not the formula. If I set it equal to the whole thing, I can do what I just did. If I set it equal to x squared, I get negative 2x, which eventually is just going to lead us kind of back to here. If I set it equal to x squared, then I have, once again, just something squared minus u, which is not actually the form. So it's not actually the sine form. So over here, this should be a relatively quick thing here. For us to do this second part, though, we are going to have to deal with that 1/2, that 2 on the top. So I need a 1/2 to come in and a 2 multiplier on the outside. I got to get rid of its constant thing. Now I have 2, and I have 1 over are a squared minus u squared du. Now we can use our sine formula, right? Let's pick it up from there. That's going to be arc sine, right?
Yep.
Of u over a plus c. And now we're just going to convert back. And that's going to be plus arc sine, 2 arc sine actually, because I forgot my 2 multiplier. 2 arc sine, u here was just x over a, which is 2, plus c. Questions here, concerns here about this one? As I stated, I mean, I think that the challenge here really begins and ends with the problem solving. How do I begin? I don't think the formulas are difficult to understand or use. I mean, it's just a formula. Plug things in where they need to go. I think the issue, the real challenge is what Parker and I did all the way up to where we started with pink and black. These first steps in pink and black are absolutely the most difficult ones to reach. Once we get there, the rest of the stars just kind of start to align for us. Questions here? Concerns here? All right. So this is probably a good natural stopping point for us if we're not going to finish everything today, because we need to pick up with completing the square. And we did review that earlier, so here's what I'll tell you to do. Since we're probably going to finish up this lesson on Thursday, which is totally okay. I'm ready for that. Watch the video. Make sure you're up to date on completing the square. Make sure you feel comfortable and confident with that. If you want to start your homework, you can. The homework here being at the very end. If you're going to start this homework, if you were going to start it, what I would recommend is that you stick to the 1 through 21 part of that, 1, 5, 9, 13, 15, 21. That's the section I would probably encourage you guys to stay in. And in fact, you might not even like all of those. We definitely didn't talk about doing problems like 25 through 43. I think you guys could be able to figure it out. If pushed enough, we could probably figure it out. But nonetheless, I think you guys can definitely knock out 1, 3, or excuse me, 1, 5, 9. I think you guys could probably do number 9. 13, I think possibly. 15 might be pushing it. Either way, I'll look for this homework from you guys next week, because that's the next time I'll see you all. And we'll finish this up on Thursday. I don't want to rush through it. Obviously, it's a little bit complicated. Next quiz is tomorrow. We'll open up tomorrow. So, of course, we can come by office hours to ask questions. It's going to open up tomorrow, be due on Friday. I'm thinking that we're still going to have our test open up on Friday, even though we are going to have our study guide day on that day. I think that might still be a good point. We'll talk about it, and if you guys have particular feelings one way or another, voice them to me, and we can go from there. If you guys want, we can always push it back and start it on Monday and have it be due Wednesday before break. So think about it. Think about where you want it. I don't know what's going on in your other classes, so you guys give me some feedback. Luke?
So if it's opens Friday, it's due on Sunday?
It would be due Monday night. The counter to that would be, if you guys don't want to do that, you guys want to have a strict day for study guide and then a strict day for test, or a strict day when test opens as its own separate day, that would be Monday through Wednesday. That would be, well, Thursday's our last day, isn't it, before break? Okay, so let's say Monday through Thursday. I'll give you an extra day. Not going to hurt you. That doesn't mean we're not doing anything on Tuesday and Wednesday next week. It just means that on Monday we would absolutely take time to look at our test and probably do the same thing on Thursday as well. Okay? Well, gang. Got a few minutes here. You need to start those problems.